Hey class, so this is chapter 15 problem set. There's only one problem set for this because we're going to do a whole bunch of AP problems as you saw in the lineup for this week. So let's take a look at question number 4. We got 14, 24, and 42 for today. I'm going to break it up into two parts, so 14 and 24 first, and then 42 second. So let's just make sure the board's working fine and we're good. Okay. So write the KC. First of all, we can do just K. We don't, if it says K, we don't have to worry about the C. The only time that we would write something down for K as a subscript would be KP. We have to note that it's KP, but if it's KC, it's just K. So for the following reactions, in each case, indicate whether the reaction is homogeneous or heterogeneous. Okay, first of all, to see if it's homogeneous, we're looking for all G's or all AQs, and this one is all G's, so this one here is homogeneous, okay? So homogeneous, let me just see if, there we go. So this one's homogeneous, which means all parts show up in the K expression. The K expression looks like this. We start off with products over reactants, and any coefficients show up as exponents. So, excuse me, I use my bracket here. I put the 2 over top like that. That's the product, so that goes on top. And then N2, concentration of N2, and that does not have a coefficient, so there's no exponent. And concentration of O2, just like that. Easy, very simple. Okay. The next one, of course, is heterogeneous. And heterogeneous because we have a solid, we have a gas, and we have a liquid. So this is very mixed up, very heterogeneous. K looks like we only have one thing that's going to actually matter. We're only writing down G's and AQs. Okay, those are the only things that we're writing down. If it's a solid, we don't use it. If it's a liquid. Pure liquids and pure solids have a constant composition, or a constant concentration is what I mean to say. But gases and aqueuses do not have a constant concentration. So the only thing we have to worry about then is the one gas in the reactants, and that is the Cl2, like this, and it's got a coefficient of 2. So it's 1 over the concentration of Cl2. Excellent. Let's keep going. Looks like the next one is also going to be homogeneous because they're all gases. So that works for us. So that means that K is going to be, and now I have 2 products and 2 reactants. So let's start with the first one. I can go C2H6 for this, and that's a 2 up there. And the next one is O2, has no coefficient, so there is no exponent with that. The next one for the bottom, for the reactants, is C2H4, and there is an exponent 2, and then of course H2O, and an exponent. Just like that, and this is homogeneous. Okay. Excellent. So as we move on, you will see for number 14 that there's 2 more. I want you guys to do this. You have to do this to get full points for the problem set. I'll be checking to make sure that you have the K for each one of these and that you label whether it's heterogeneous or homogeneous just by checking to see what they are. Okay, let's move on to 24 then. 24 is a special case where we have, this is our target. This is our target equation. That's the one we're looking to get by adding these 2 together that you see down here. Okay, and we can find then the total KC for both equations by multiplying, but we may have to do some work on these equations. The first thing I do is I look to see which parts are reactants and which parts are products. Notice for the target equation, I only see a 2NOBr as a product, and there's only one place that has the 2NOBr, and that's over here. So the first equation is not going to be flipped. We're going to keep it just like it is. However, in the second equation, notice that we have N2 and O2 as products instead of reactants. So I'm going to have to flip the second equation. By flip, I mean I'm going to have to move N2 and O2 as reactants and then I'm going to have to move the 2NO as a product. Okay? When I do that, here's how the Kc is affected. No longer is the Kc 2.1 times 10 to the 30th. Now it's 1 over 2.1 times 10 to the 30th. Okay, so I have to take the 1 over, or the inverse, or the reciprocal of 2.1 times 10 to the 30th. Okay, so I'm still going to multiply to get this Kc down here. I have to do the 2.1 times, and then it will be 1 over. There we go. 1 over 2.1 times 10 to the 30th. Okay? So we'll figure out what that is as soon as we make sure that we have all the pieces looking like it should. So here's why we flipped the bottom equation. We flipped the bottom equation so that we can cancel things that are on opposite sides of the equation, such as, notice that 2NO is a reactant on this side, but it's a product on this side. Okay, I have NO on both places, a product and a reactant, which means I can cancel them. And if I have equal numbers, as in 2NO and 2NO, I can completely disregard. So that means that I have N2 plus O2, because neither of those cancel with the other side, and I have Br. So I write everything that's listed that does not cancel. And then on the other side here, I have 2NO Br, like that. And notice that that matches exactly my target equation. Okay, so we know we did the right thing. Now when we go to calculate the K of the K equilibrium constant of the total expression, then I go to the calculator and I take I'm going to do the 2 times, the 1 over 2.1 times 10 to the negative 30th, or to the positive 30th. I'm going to do that first. I just type in 2.1 EE30 equals, and then I have, on the iPhone, I have a 1 over X button. I hit that and it gives me, so this is going to be 2.0 times, and that's this whole number here. It's 4.76 times 10 to the negative 31st, like that. And I take 2 times that then. So times 2 equals that. So that gives me 9.52 times 10 to the negative 31. And that's my answer for number 24. Okay? So that's how I did that. That's the end of the first part of this, number 14 and 24.